All right, let's dive right in. Today, we're talking about an idea that's, well, it's both incredibly simple and at the same time absolutely profound. It's this idea of a hidden code, a sort of instruction manual for the universe that shapes everything, and I mean everything, from the smallest particles to the biggest galaxies.
So let me just start with a huge question. What if there was one single elegant rule that could explain it all? I'm talking about connecting the dots between why trees grow the way they do, why planets move in predictable orbits, and maybe, just maybe, even the meaning of your life. Sounds pretty ambitious, right? Well, that's the incredible journey we're heading on.
You know, for more than 100 years, this has been the holy grail for physicists. They've been on this epic quest for what they call a theory of everything. The dream of finding one single, all-encompassing framework that describes literally every physical thing in the universe.
But here's the thing. For a theory to truly explain everything, the standards are impossibly high. It can't just work some of the time or only in certain places. Nope. It has to be true across all of space and all of time. It has to connect the bizarre world of tiny quantum particles with the majestic cosmic dance of galaxies and everything in between. It has to cover the whole shebang.
So what could a rule like that possibly be? Well, the answer might not be some crazy, complicated new equation. It might be a principle that's been hiding in plain sight this whole time, a fundamental rule of efficiency. It's called the principle of least action, or PLA for short. And the core idea is stunningly simple. Basically, anytime a system moves from point A to point B, it will always choose the path that uses the least amount of energy over time. In other words, nature is lazy, but like in the most brilliant way possible.
Let me make this really concrete. Just picture a ball at the top of a hill. It's just sitting there, full of potential energy. Now, when you let it go, does it take some wild, looping, scenic route to the bottom? Of course not. It follows the most direct, efficient route it can find. That path, the one of least effort, is the one that minimizes the action.
And this right here shows you just how crucial this principle is. In our universe, governed by least action, we get stability. We get atoms that can form, planets that have predictable orbits, and the conditions for life to exist. But just imagine the opposite for a second, a most action universe. It would be pure chaos, total mayhem. Particles would be unstable, energy would be wasted everywhere. There's just no way life could ever get a foothold.
So here's where it gets really interesting. This one simple rule of efficiency doesn't just describe how things move, it actually builds complexity through a process we call self-organization.
This whole process starts at the tiniest possible scale. The principle of least action is what drives quarks to clump together. Why? Because it's a more stable, lower energy state for them to form protons and neutrons than it is to just float around on their own. It's more efficient.
Then those stable atoms do the same thing. They combine to form molecules, again, because they're seeking a more stable, lower energy state. And this process gives us everything from a simple water molecule to the incredibly complex and stable structure of DNA. And it just keeps going. The molecules combine to form cells, and then those cells self-organize into complex organisms. Every step up in complexity is also a step towards a more stable, energy-efficient arrangement.
And believe it or not, this scales all the way up to us. Humans naturally form groups, tribes, communities, companies. Why? Because cooperation is simply more efficient for survival and for getting things done. Every single level of organization, from quarks all the way to companies, is just a new, more stable structure built on that same foundation of efficiency.
Now, this universal drive for efficiency leaves behind a stunning visual signature. These beautiful repeating patterns that you can see all across the cosmos. It's like the universe's underlying code made visible. These patterns are called fractals. They're structures that look similar at different scales, whether you're zoomed way in or way out. You can think of them as the fingerprints of the principle of least action, showing us how nature solves problems of optimization. And once you know what to look for, you see these patterns everywhere. They are all solutions to an efficiency problem. Trees branch out to maximize their exposure to sunlight. Rivers fork and split to find the path of least resistance to the sea. Our own blood vessels form a fractal network to deliver oxygen with the least amount of effort. Even the majestic spiral arms of galaxies are shaped by this exact same drive.
Okay, speaking of fundamental patterns, let's take a quick, kind of curious detour for a second. Have you ever just noticed how often the number 3 seems to show up?
I mean, it pops up in some really fascinating places. In physics,
We have 3 spatial dimensions, and protons are made of 3 quarks. In biology, DNA has 3 main components. The pattern even echoes in our culture and religions. While it's just a parallel, this constant recurrence kind of makes you wonder if 3 is a truly fundamental number for creating stable structures.
Okay, so we've traveled from quarks all the way to galaxies. Let's zoom out as far as we can and ask the big question. What's the ultimate cosmic payoff? What does all of this actually mean for us? So, if it's true, if efficiency really is the source code of the universe, what are the implications of that? Where do we fit into this grand efficient scheme?
Well, here's a mind-bending idea for you. Some theories suggest that our entire universe might be the ultimate efficient system, perhaps even one that exists inside a black hole, which is basically the peak of cosmic efficiency.
And if that's even remotely true, it leads us to the biggest question of all, doesn't it? In this vast, efficient machine of a universe, what is the meaning of life? Well, from this perspective, the answer is elegantly simple. The ultimate aim of life, in a universe that values efficiency and stability above all else, is simply to continue, to persist. The most efficient thing for life to do is to just keep on living, to pass its information forward. So maybe that's the answer right there. You can think of the universe as a grand cosmic battery, slowly running down. And the principle of least action, this fundamental code of efficiency, is simply the circuitry that maximizes that battery's life, allowing for the emergence of incredible, complex, and beautiful things along the way. Things like us.